All right, folks, it's Bass Action back in action here. In this video, what I'm going to work through is how we can handle unit circle problems when either the angle that we're given is negative or the angle that we're given has an extra rotation in it. So let's start here with our negative rotation examples. You have three choices for how to do this, so I'm going to go through them in order, and I will apply that to each problem so you can see it a couple times, and you can decide which way is going to work best for you. So the first option, and although I really like this option, I do think it's nice from the perspective that it helps review some things. It's not the best option for use everywhere. The first option is to work with your odd and your even properties. Okay, so handling, and I'm going to divvy this up here. So if we wanted to look at this, we would say that sign is negative or sign is odd. So we can pop the negative. This would be a pop it. Sign is odd. So we could pop the negative, and then we would rewrite this problem as a negative sine 7 pi over 4. So that's one way to deal with that negative. In which case you would say, oh, 7 pi over 4 is in the fourth quadrant. Sine is negative in the fourth quadrant, so you would say a negative radical 2 over 2. But we still have the negative from up here, so we would have a negative times a negative, and it would become positive. This is kind of that worst case scenario where we end up with this double negative, and it's a little messy for people. The next option for this is to just handle the negative angle. So to deal with that negative rotation and say, oh, well, a negative 7 pi over 4 would just rotate this direction. So rotating a negative full rotation would be negative 8 pi over 4. So negative 7 pi over 4 is in the first quadrant. And now we just deal with what is sine of pi over 4, because remember we get to ignore this part now. What is sine of pi over 4 in the first quadrant, and there is that positive radical 2 over 2. The last option is to add a whole rotation to this angle. So just add using coterminal angles. Add an 8 pi over 4 to 7 pi over 4, which just turns it into sine of pi over 4, which gets us to the first quadrant and right back to where we were. So those are our three options. So let's look at those again over here on our next one on this cosine problem. And on this cosine problem, cosine's kind of nice to deal with the odd and even properties because cosine is even, and if cosine is even, we get to drop the negative. So we get to just do this problem as a cosine of 5 pi over 6, which is a pretty straightforward way to do this problem. Puts us in the second quadrant. Cosine of pi over 6 then is a square root of 3 over 2, and of course it's negative in the second quadrant. Oops, negative 3 over 2. Looking at our next options, dealing with the negative rotation itself, rotating a negative 5 pi over 6 puts our angle in the third quadrant. Cosine's still negative in the third quadrant, so cosine of pi over 6 is still a radical 3 over 2, but in the third quadrant it's negative. Last option again is to add that whole rotation, so adding 12 pi over 6 gets us to a sine, I didn't mean to say sine there, gets us to a cosine of 7 pi over 6, which is also in the third quadrant, which gets us to the negative radical 3 over 2. Again, it makes no difference which of these three methods you're kind of liking for your own brain. You just do the one that works best for you and then practice that one. Looking at our cotangent, cotangent is an odd function, so we're going to pop the negative. This will become a negative cotangent of 4 pi over 3. It's a really messy 4 there. Then we sketch the 4 pi over 3. That's going to put us in the third quadrant. Cotangent would normally be positive in this quadrant, but our answer will be negative. The cotangent of pi over 3, remember once we get the angle, we only have to look at the reference angle. That would be radical 3 over 3, but we will write it as a negative because of our negative out front. We can sketch the negative angle. Negative 4 pi over 3 lands me in the second quadrant because I'm rotating a negative 3 pi over 3 and then one more. Then we know the cotangent would be negative there, and then our answer would be negative radical 3 over 3. The last one would be to add the whole rotation. That would turn this into, we're going to add a 6 pi over 3. That'll turn it into cotangent of 2 pi over 3. Puts us back in the second quadrant, which is exactly what we expected to happen. So that's our negative angles. The next thing that we want to look at, this is where the coterminal angles is also really important. We want to be able to easily recognize that this angle here is more than a whole rotation. Remember, we can identify a whole rotation by looking at that denominator and thinking of that in terms of 2 pi. So a whole rotation would have been 6 pi over 3. So obviously this is more than 6 pi over 3. In fact, it's 2 extra rotations. So 14 pi over 3 minus 6 pi over 3, and we're going to do that twice. We'll turn this problem into sine of 2 pi over 3 because we're subtracting 12 pi over 3. That's the angle that we're going to evaluate. 2 pi over 3 is in the second quadrant. Now we can just look at pi over 3. Our answer should be positive, and our answer will be a positive radical 3 over 2. Looking at another one here, 17 pi over 4. We're going to figure out what's our whole rotation. Whole rotation is 8 pi over 4. Bobbled there, okay. Again, we have 2 full rotations extra rotations inside this 17 pi over 4. So we'll rewrite this as a secant of pi over 4 after we take out the 2 extra rotations. Now, we're going to remember this is the reciprocal of cosine. Pi over 4 is, of course, in the first quadrant. It would have been radical 2 over 2, but the reciprocal of that is radical 2. So our answer is a positive radical 2. Last one that we're going to look at, you've got a couple options on this one. Okay, now we're going to combine extra rotations and negative angles from the previous problem. So we would have a whole rotation of 12 pi over 6. Just like before, you could deal with the odd and even. I'm not going to do that on this one. I'm just going to work with the rotations and the coterminal angles. You can add one rotation and turn this problem into a cotangent of negative 5 pi over 6. Or you can add 2 full rotations till you get something positive and get cotangent of 7 pi over 6. Either way, we get our angle in the third quadrant. Cotangent, and now, again, once we know the quadrant, we only have to look at the reference angle. Cotangent of pi over 6 is going to be our radical 3. And then in the third quadrant, it would be positive. So that's our final answer on that one. Okay, so that is our negative and extra rotations. You're going to see more practice with this on page 23. When you get to that practice today, that's going to have some of those slipped into there. You won't see this on any of the Canvas quizzes, but you will see it in that extra practice, and you will see it on the test.